Alright folks, the challenge is on. We're now going to add and subtract rational expressions. We're going to take a few days to do this. A little more complicated than multiplying and dividing. But if you get the pieces, you should be alright with it. Alright, so to start with, I basically want to add 3/10 plus 6/10. And of course, going back to elementary school and in 5th grade, nice and easy. You got a common denominator right here in the tenths. So all you have to do is keep the common denominator, which is 10, and you add or subtract the tops. In this case, 3 plus 6 is 9, and bingo, you have that. So that's our rule. If you got a common denominator, real quick, add or subtract, and we're going to move from there. I don't care if the bottom's a letter or a number or whatever symbol, you can do this. All right? All right, so now the harder part is what if they do not have the same denominator, have a different one. For example, 2/5 and 1/3. Well, here's an example of 2/5. I got 2 bars shaded out of 5 is how you draw them. 1/3 is 1 out of 3. Notice they're both one whole number here. And I got to combine the two. Well, it gets a little messy. I put the 2/5 here and the 1/3 on one. How do you know where that thing ends? It doesn't end at a nice point like right here at fifths. It's somewhere between 3/5 and 4/5, and you can get around that. But we have to be able to deal with this another way. So you need a common denominator, bottom line, and that's what they're telling you in this piece. And one way to do that is just multiply the two denominators together. So in this case, fifths and thirds make 15ths. And then so on 2/5, obviously I can change that into different parts on 2/5. You go 2/5 of the way, you'll actually end up being, what did I multiply to get a 15 from 5? It's 3, so I get 6 sections here, so 6/15 is the same thing as 2/5. And for 1/3, to get 15ths, I got to multiply by 5, so 5 times 1 is 5, so I got 5 in the blue parts of the 15ths, for a grand total of 11 pieces out of 15 shaded. Okay? Same thing down here. If you look at it with the fractions, you can take it that way. To get 2/5, I multiplied by 3 to get 15, so 2 times 3 is this 6 right here. For 3 times 5 gives me 15, so 1 times 5 is 5. And then we do what we did on the previous page. They're both 15ths now. So 6 plus 5 is 11/15ths, and you get that answer. And so here's your rule. As long as B and D aren't 0, remember we can never divide by 0 down here. You multiply the D times the A, and you take the B on this one times the C, and then you combine them, and add and subtract are the same rules. So we're going to get some practice in that starting right now. Okay, so our first example here is number 2. We got a 3/20ths take away 4/15ths. We do not have a common denominator. Okay, so if we want to use just the 2 pieces, it was pretty easy. All I do is take the 3 times the 15, and then minus the 4 times the 20. You do that one that way, that one that way. All over, and we put the 2 together, 15 times 20, or 20 times 15. So what do I get here? I get a 45 minus 80 all over. When I do 15 times 20, we get 300. So that thing will be a negative 35 over 300. And of course, I can reduce that to a negative 7/60ths. Okay, so if I continue on here, I just want to show you something here. If I do the problem another way too, take a look at this. We know 20 is 4 times 5, and 15 is 3 times 5. They both already share that 5. So that piece we already have. So what's the piece that we don't have? Well, if I take the 3 and put it up here, and the 4 I put it up there, then we can have the common piece that we need. So let me show you what happens if we do that. So if we do that, then I'll do it in blue here. I actually get 3 times 3 minus 4 times 4. And that's all over the common denominator of, we need the 3, we need the 4, and we already had the 5. Okay, I don't count the 5 twice because they shared it. So if I do the stuff here, you now get 9 minus 16 over 3 times 4 times 5 is 60. And when you're done, negative 7/60ths. Now we're going to be using this technique coming up a little bit because we don't want to always use the whole darn common, the 2 denominators. We want the pieces that are missing. So this allowed us with smaller numbers. I didn't have to get up here at 300. We kept it down at the 60 right away. So just so you're aware of that. Let's move on to the next one then here. This one, we don't have anything in common other than a 1. So I will take the 4 that way. I will take the 5 that way. So if I'm doing this, I get 5 times the pi plus 4 times the radical 2 all over 4 times 5. And really, that's our answer right there. 5 pi, I can't do anything with. Cannot combine that with 4 radical 2. And the whole thing is over 4 times 5 is 20. So that is our answer for that one. It's the answer for the one before. Last one right here. What do we got here? Well, they all have an M if you notice. So if you take my thing from before, we don't need an M. The only thing that's missing is the 2. The B has the 2 in the bottom, but the other two guys don't. So I'm multiplying this one by 2 and this one by 2. If I do that, you will get 2A plus the B minus 2C, and the whole thing is over. 2M is my common denominator. And that is your answer. It's that easy. Just find the missing piece. They all shared an M here. They did not all have the 2. It's the only other piece there. So I put the 2 in the top with multiply it by the pieces that didn't have it. And there's your answer. None of these are like terms. So we are done. That's our answer. All right, move on to another couple to take a look at. Okay, same scenario. We got the same 4 and 5 again. So we're going to take the 4 the one way. So we will have 5 actually times the first part, the A plus B. Because I'm bringing that up on top here. And the 4 needs to go that way because it doesn't have it. So plus 4 times the 2A minus B. And the whole thing is over 4 times 5. Okay, so I get a 5A if I distribute, plus 5B, plus 8A, minus 4B. Remember, I'm just distributing times everything. That's how I'm getting the pieces. All over 4 times 5 is 20. What do I have in like terms here? Well, I got a 5A with a 4A, and I got a 5B and a minus 4B. So 5A plus 8A is 13A. 5B minus 4B is 1B. And the whole thing over 20. And there's your answer. These are not Sherlock Holmes type things you can have fun with, like we did in the other parts. All right, 2 more to go. This one right here, once again, we already have an x, don't we? That's common. This x is common, not the square part, okay? So just the x. So this is really like 3 times x, and this is 5 times x times x. So they have this piece in common. I'm not going to use both. If you want to use the whole thing, you can. You just got to reduce at the end. So I'm going to take this 5x times the 4. So 4 times 5x minus 3 times, and what pieces does this one missing? Just the 3. And the whole thing is all over a 3 times a 5 times an x times an x. There's 2x's total in the bottom. So we get 20x minus 9 all over 15x squared. And that's all we can do. Remember, yeah, I could reduce individually right here. If I do reducing stuff like this and put this over this and the other piece over it, you're going to get back to what you started with. That's not what we want to do. There's nothing else I can factor out. There's nothing else that's going to cancel. So, yes, indeed, this really is our answer here. Okay, on to the last one for today. All right, this one we're going to jump up to another level. You're taking a look at this. This has got more complicated stuff here in the bottom, stuff like that. And they definitely are not like terms, so I can't just go and add them. So, this is where factoring comes back into play. This one, they share a 2 and they share an x. So you factor out a GCF of 2x. You are left with 1x. Plus, you take the 2x out, it's a 1 there, okay? This side over here is a trinomial, so you factor it into 2. So you get x and x. Bring down the minus sign. Boss says it has to be different, so that's a plus. And your factors of 4 that subtract to 3 are 4 and 1. Okay? Now, notice, this here is the same as this here. I do not want to use that. That is part of my GCF in the bottom. So x plus 1 is in the bottom. Okay? I will also need that 2x in the bottom. okay? Because that right here is going to go on top. So that's plus the 5 times 2x on this side. And the x minus 4 is going to go this way. So that's 3 times the x minus 4. So I need an x minus 4 in the bottom. Definitely much more complicated than before. All right, now we're going to turn around and distribute. So I get 3x minus 12 plus 5 times 2x is 10x. All over, and we do not want to put these back together. Leave them separated. Don't go trying to crunch things back together and do tabular and all that. However, on the top, I've got a couple of common things here, don't I? What's 3x plus 10x? 13x. Minus a 12, and then all over this 2x, x plus 1, x minus 4. All right? So that's our lesson. I guess I got a phone call coming in. I'll talk to you in class, and we'll see you later. Look at the summary, though, first down below.